Alright, now that we have seen the binary searching technique for finding the square root of a number, let's quickly write the Java code for that and validate various scenarios. So here I have written the new file and all common code that we need for calling that function and everything I have declared. So let's just quickly dive into the implementation. So here since I'm going to use binary searching, I'm going to define helper variables. Start, I'm going to initialize it with 0 and end will be initializing it with number itself. Now along with that, let's also define middle and initialize it with -1. Now as long as this start is less than or equal to end, whatever we have, in this case what we will do, we will calculate the middle. Middle is nothing but start plus end divided by 2. Now what we will do, we will calculate the square of this middle. That means middle multiplied by middle, if it is equal to whatever the target that we have been given, in that case the actual square of this middle is giving the it's not start, we need to compare it with the number that we have got. If at all the squared value of this middle is equal to the number that we have got, square root of this number is nothing but this middle, right? So here we will simply return middle itself. Okay, if this is not the case, what are the other scenarios? The squared value of this middle could be greater than this number, or the squared value of this middle could be less than the number. So here, to check those two scenarios, if at all the squared value of the middle is less than whatever the number that we have got, in this case what we will do, we need to find the square root, right? It will be somewhere greater than whatever the middle we have right now. So we will simply update the start with middle plus 1. If this is not the case, obviously the other scenario is the squared value of the middle will be greater than the number. In that case, what we need to do, we will simply update the end with middle minus 1 such that we will be finding the square root of that particular number till middle minus 1 index from start whatever we have. Now here the other scenario that we need to handle once we come out of this while loop is that if at all the number that I'm passing, let's just say I'm passing 4 is nothing but 2 square, right? So the square root of the number 4 is nothing but 2 and it has a valid square root. But let's just say if I'm passing the value of 8 does not have a actual square root, right? I mean the square root of 8 is not a whole number. It will be something like 2.8 something, right? So in that case, since it does not have a proper square root, what we will do, we will return the closest integer to that, which is nothing but 2. So to handle that sort of scenarios here, what we will do is, whatever the start that we have after completing this while loop, we will simply return -1, because as we continue this logic, whatever the value that we get inside this start after completing this loop will have one value greater than whatever is the closest square root for that particular number, because here in steps we are incrementing it by 1. That's why in the end we are reducing it by 1 and returning it. So here I did a spell mistake, I just corrected it. Okay, so that is the effective way of finding the square root of a number using binary searching. Now let's just test it with valid numbers in the beginning. So the input that I'm passing is 9. 9 is nothing but 3 square, right? So if I run this program right now, the output should be 3. So if I run as Java application, see the output that I have got is 3. Okay, the output is 3. And to test the other scenarios, let's just say the output that I'm passing is 12. 12 does not have a proper whole square root, right? So it should be something like 3 point something, so the output should be 3 as well. So that is what we have got here as well. Let's just say the input that I'm passing is 100. 100 is nothing but 10 square, so the square root is 10. That is what we have got. Now let's just say that input that I'm passing is 101. So 101 square root will be something like 10.001, something like that. So the closest integer is 10, right? So the output should be 10. Okay, so whatever the logic that we have written is working absolutely fine. One thing that you have to notice here, I haven't written any code for handling the negative numbers. If at all, if your problem statement also includes that there is a possibility that user can pass the negative numbers, and you can simply return, you can simply add a check here. If at all the number is less than 0, you can return whatever the appropriate value based on the discussion that you can have with your interviewer. Anyway, I'll not be adding that logic. I will leave it up to you based on your discussion with your specific interviewer. Anyway, that is how we write the code for finding the square root of a number using binary searching technique. If at all, if you want to check out the brute force solution also, I will put the problem link in the description. You can use that link and check out codingpal.org for brute force solution as well. But anyway, this is the effective way of finding the square root of a number using binary searching. Okay, that's it for this one. I'll see you in the next problem.